Okay, great. So, hello, welcome to Texas Open Data from soup to nuts and end-to-end use case for the Texas Open Data portal. So I am a feral cat colonist. And so just for some context of what we're looking at before we start, this is a Jupyter notebook utilizing the RISE extension, RISE. And it's great because it lets you do presentation style stuff. Oh, am I not on?
I can hear you just fine.
I can hear you too. That's no problem.
Okay. So yeah, this is a Jupyter notebook utilizing the RISE extension. You can get all of this. I do all my stuff through Anaconda, so all of it is self-contained within Conda commands, which is great. So it makes it like a PowerPoint. So it's going to look really minimalist, and it uses obviously Markdown, where there's text that's not code. Okay, so I know a person at my old job that just loves the phrase from soup to nuts. So, back in the American 1800s, right? Every meal was a full course meal, right? So you've got all sorts of different types of soups. And then the meal, of course, was over with port and nuts. So personally, I think that Portuguese wine 3 times a day is a bit excessive. But I do love the idiom. So let's use it a lot, right? This is the old website that Texas uses for childcare centers, right? And we'll just look at it. It's something. This is what it looks like, right? This is, oh, come get our data. And then if you click on this button, it'll give you a CSV, which I don't really care for so much. So I wrote an email, right? And I said, hey, guys, it would be great if I could get a REST service or something to grab this data from y'all on a regular basis. And I had actually talked to this department in our state government 2 years prior. And basically, they told me that, oh, hey, the state, they have this open data site, but we don't really use it, but we're considering using it. So with the speed of government, I figured that's where we were still at. So I made some assumptions. And when you assume things, people will correct you. So this was my correction email that I got. And this fellow said, hey, we actually have something in an open data portal, which is super great. Super great. So this is the Texas open data site. It uses Socrata as the backend, and if you wanted, you could export that same CSV out real easily. But that's not really the way to do things, at least long term, right? If you only have to do the thing once a year, then maybe you'll do that. But if you want to have data at some frequency, then you really need to automate it. Now, before doing this, I had never actually used the Socrata API, but it was not hard to pick up. And that's kind of why I wanted to give this presentation at all, because I don't want people to be scared about new things. So we're going to learn new things together. The things that I wanted to do, obviously, were to make it spatial and to keep it up to date without having to personally type in the information or run commands and stuff. So the Socrata documentation is actually really good. It's dynamic. So when you're looking at examples, it's going to give you the actual data set that you're working with, right? So here's our number of rows. It's going to tell you about the fields and what type the fields are in, right? And then some examples of how to use it using their API. So super neat as far as API documentation goes. Sometimes that can be pretty scant. So it's called the SODA API. And then we can also see that there's different output types, right? So if we click on the API button, and if we click on JSON, then you say, oh, we could get it as a CSV, a GeoJSON, or JSON. So we'll just change the URL, right? So right now it's just like this. If we add a, what was that, GeoJSON? We add a GeoJSON to that, and then I can't do things the way I'm supposed to. Oh, here we go. That's what it's supposed to look like. All right. So for Python people that haven't done this kind of thing before, it's just a series of dictionaries, right? So a feature collection is a type of dictionary, and then it has a list containing all the different types of features that are inside of it. Anyway, we're not really going to dig into that too terribly much. So before we do anything, we're going to do this, and we're not going to talk about this, but basically we'll talk about it just a little bit. If you're working with pandas inside of a Jupyter notebook, then you want to be able to control how it displays so it's not horrible. So here are some display options that you can use. So when using Geopandas and pandas, the convention is to use PD and GPD. So if you see it in a script, that's what it is. Someone decided that's what it needed to be. And so everyone does that. So when you write, pandas dot blah, 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 you're going against the grain. Everyone is expecting pandas or Geopandas to be written like that. Anyway, so what we're doing here is we are storing the URL in a variable. And then we are using the Geopandas function read file because it can read files on your local network and then also URLs, which is why Geopandas is great. And then this, of course, is an F string. If you're not using F strings yet, you need to be using them because they are literally the best. So it's saying, hey, there's 1,000 records in the data set after we put in our data frame variable. This is what it looks like. It's kind of nice. And look, it's got a geometry column, and that's cool. Okay. What is super cool is how easy Geopandas is to use with data. But what's less cool is that we're definitely missing some data, right? So if we go back here to our main page, we can see that there's about 14,000 records in the data set. And then somewhere else, there's also stuff. Here we go. There's also 14,000 records. So we need a little bit more. Looking through the documentation, there's a section on paging. With the evolution of the API, now there's no limits, but if you wanted to specify a limit, you could. If it was really big, you might time out, so you would have to write something to handle that. But this is not big, so we're not going to worry about that. You're going to see this line over and over again. This is a regex, a regular expression that gets rid of some artifacts that are created by the SODA API. So it's there. We can just ignore it. It just removes some columns that we're not going to need. So by putting this $sign, putting this $sign limit equals 50,000, we're telling the API that it can give us up to 50,000 records from this data set. There's only 14,000 records in the data set, but you'll see now that we grabbed them all, which is great. So now how do we put it into our working space? We could use Fiona or Geopandas to write it. We could use ArcPy's JSON to features function. But what I like to do is that the ArcGIS API for Python, because it's new and it's shiny and it's useful throughout the ESRI verse. So if you're an ESRI shop like we are, definitely something to utilize. So that's what we're going to do. The ArcGIS API for Python has its own data frame implementation that is different from a geodata frame. So they call it the spatially enabled data frame. And we'll have to use that to push it into our stuff. So they have a convenience function for it, which is great. It's kind of a one-way thing. There's not a convenience function for two geodata frame. But if you have a geodata frame to give it, then you can just use this. So we're calling ArcGIS features and the geo accessor. And we're saying, hey, this variable here is a geodata frame. So turn it into a spatially enabled data frame. And it's the same data, which is great. Except instead of a geometry column here, we now have a shape column. And the geometry information looks like ESRI stuff, which is great. So then what we're going to do is we are going to push that into a feature class, right? And again, we have a convenience function here called toFeatureClass, and we're going to give it the location of where the file geodatabase is at. And by default, overwrite is set to true. Throwing that out there, you don't have to have that. If you don't want that, then you need to set this to false. So it went ahead and spit out where it needs to go. So we are going to take a look at that inside of ArcGIS Pro to see that it did the thing that it was supposed to do. Great. Obviously, this is a T-Mobile map. No, so this is the stuff, right? Which is cool. Totally cool. That's exactly what we wanted, right? I mean, kind of. So I was raised here in Texas in a public school, and there's a lot of Texas-specific patriotism that we're taught. It's like, oh, we're the biggest, oh, we're the best. Oh, forget about Alaska. We're really the biggest, But I don't think that Texas is supposed to be that big, but it is. Oh, yes, and then also, if we wanted to take a look at the fields, we'll see that they are all type text, which is not great. If you want to do stuff with your data, if you just want to look at your data, I guess it's fine. So the API for Python is not good with dirty data sets, and it has like weird schema issues as well. So some of the things that you might have to do are to convert all of your object columns to string columns, which is now a type as of Pandas 1.0. But generally, anytime you do an ETL or an ELT, there's going to be significant data engineering, right? So you need to be familiar with the data that you're trying to ingest and kind of work on its idiosyncrasies, and you'll be spending 80% of your time just trying to clean and massage the data before actually doing any value-added work. So just a word of caution. I'm sure this will get better as time goes on, but it is an issue right now, and some of the error messages are cryptic at times. Okay, so this is the other thing we can do is we can open our geodata frame and call dtypes on it. And this says, oh, object, geometry, which makes sense. First, GeoJSON can be formatted with data types, right? So here's an operational number. Well, let's not do that. Here's a deficiency score, right? And they're wrapping it in quotes. If this was not wrapped in quotes, then this deficiency score column would be a number column. But because they went ahead and wrapped every single thing with quotes, everything is a text column. So there's that. And then Pandas is smart. It will interpret your columns automatically if it senses things of like types, right? So if you have a column and it's all numbers, it's going to know it's all numbers. If you have a column of all numbers except one, which is the word, this is not a number, right? Then it's going to say, oh, obviously it's a string column. Pandas type for strings back in the day was the object type because it stores types, things. You can do object types like a list or something. So instead of manually going to this thing and figuring out what all the columns are supposed to be and handwriting a dictionary, let's pull that data out programmatically. And we can do that by downloading the CSV, right? So we will just change the format in the URL to .csv. Nothing else changes. And we're going to use regular old pandas to read the CSV. The same thing as read file. It will read a URL in addition to a file. And then when we call dtypes on our pandas data frame, we're going to see that we have some integers, some floats, again, lots of objects, and some more integers, right? These are all the deficiency scores that I was talking about. So those are good. Then next, what we're going to do is in a for loop, we're going to say, hey, for every column inside of the pandas data frame, we are going to call the geo data frame by the column name that we're using from pandas. And then we're going to remake this column as the same type that is the pandas CSV column. That's a lot. It looks like a lot. All we're doing is pointing to the other column and say, hey, use that data type instead. And so that's what we're going to do. This is a general try except. And so you kind of know what's gonna go on. If you just try accept everything, that's lazy. You should understand what the limitations of your data are. And so here it's saying, hey, the location address geo field is not in the CSV, and of course it's not in the CSV because it's not in the geodata frame because we took it out. Anyway, so there's that. It works. Then now that we have the new data types, we are going to use the spatial data frame here, the spatially enabled data frame. Oh no, what is this? An execute error. Can't get a schema lock, right? So that's because I'm a big dummy and had the program open. Totally didn't plan that painstakingly or script it out or anything like that. It just happens to happen every time I give this presentation. And now it works. So here it is. And then we can okay. So now our stuff in ArcGIS Pro has the data types, and I'm not going to keep opening it because that would be annoying. We can look at the data at the end though visually. So when I wanted to use this, right? And there's a SOTA function to where you can specify a bounding box, and if you ever wanted to make a bounding box, bboxfinder.com, super easy to use. It spits out your coordinates there. So this is actually where I started out with the project because I read through like all the API documentation. I was like, oh, this is gonna work. I'm excited. And so I did. All right, so here's our bounding box. Here's our column. Then we're appending this part of the SOTA API to the rest of our URL. We're just saying, hey, where inside of this within box function, use the geo column name and then use the bounding box coordinates that we gave you. And that's all there is. So now we can call Geopandas has a .plot function, which is super nice. The ArcGIS API for Python plotting function requires you to instantiate a map first, and it's kind of a hassle. So the plot works fine from Geopandas. That's what we're going to use. So you can see this is roughly a rectangle, right? I mean, I guess all plots are rectangles, but I mean it looks right, and the lat long looks right as well. We don't see a continental scale or anything, so it works. So if you wanted, you can also query against specific data and not just do geo queries. So this is this is that we're going to use a in statement, right? So where the county column is in either Collin or Denton, our municipality straddles the border, so we have to call both of those things. And then this is what happens, right? 1,000 records, just about right. We're pretty urbanized. But then, as you can tell, this is definitely the United States. That's Florida, and yeah, we're still pulling a bit too much data, right? And definitely, I don't want to like mess with 1,000 records, right? We're not that big, and I don't want to be spending that kind of time with that, right? So the workaround for this is to use zip codes, which is our kind of a unit, kind of not a unit here in the US. There is not a zip code column. So inside of the location address column, it says, 123 Main Street, zip code, blah, 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 Prosper, Texas. So we are using some pandas functions, right? So instead of using the SOTA API to do whatever, we're just calling, I guess we could have just called the two counties that we're looking at. But we're using the entire Texas data set for here. And we're saying, hey, this pandas function, we're going to filter out anything where the record contains, this is a regular expression right here, any of these numbers, right? So if you had a daycare at like 75009 Main Street in El Paso, it's going to grab that record. 10,000 addresses are somewhat rare. So this is an acceptable, limitation to this, right? It's going to get less than the counties. Maybe we'll have some errors, but then we can figure out what those are and solve for them. So here we go, 250 records, which is about right for all the zip codes that the municipality is a part of. So that's fit for purpose, which is nice. So outside of the, things outside of Texas, the other issue that we have is that the geocoder, the state of Texas, this department anyway, is using. So we have a statewide address layer. We have multiple statewide address layers, but they're using Bing, Microsoft's Bing, to geocode their data. So again, I'm assuming it's because the data doesn't exist natively on their end in a GIS. So with the Bing geocoder, what's going to happen is it's either going to sit down along a street center line, according to whatever Bing says that street center line's range is, or it's just not going to geocode at all, right? Or, it'll go somewhere else, right? That's not in our municipality. So my use case for this data is to create parcel-based information, right? So these are the drug-free zones, and the sex offender restrictions are all, you can't be within X number of feet within this place. And that place is defined by the land ownership underneath that building, right? So it extends out to the parking lot or whatever. So for this data, I could try a join based on an address, or I can maintain the geodata, the coordinates on my end, and update just the table records from the state. So for us, this is a high value data set since we're using it for things that have legal ramifications. So there should be some sort of quality control. For me, this means foregoing an automated geocoder. I'm not like the best at geocoding things. I could build one, but at the same time, the data set is small enough that we can get away with manually looking at these things and manually correcting the geometry from the state. However, if we had like a bunch of daycares, hundreds, the turnover was really quick, then I would obviously want to do something like a geocoder that's more automated. But for this particular data set, that's my choice. Okay, Okay, so what we're going to do here is after we've created our zip code defined data set, we're also going to grab a copy of the same thing, call it our production data. So instead of using joins inside of the ArcGIS environment, we are going to use joins inside of pandas because it's super easy. You just need to set the index here, which is the operation ID, and then we'll join it based off of the operation ID from spatial data frame, production data, and then it's a left join. And then for the left-handed data set, the prod, we're going to do an underscore production. So we know, hey, this is the production data, right? And it'll give us some tricks to use as well, right? So here's the data frame with little prods at the end. And then when we get to the end of that, and it's just the column names regularly, right? So this would be the updated data from the state that we want to collect every whatever period of time. So what we're going to do next then is we're going to drop the state's shape column, right? Because it's not correct and we spent a bunch of time making the geometry correct, so we don't want to use it. Then once that column has been dropped, it's gone. We're going to rename the production shape column, the production geometry, the stuff that we've manually placed on the map. We're going to rename it just shape. Then we can drop all of the columns that contain underscored prod. So this has the effect of dropping all the table data for our records for these child care centers, and then replacing them with the same schema, same columns as given by the state, right? So the effect then is to update our data in place. So what you could then do is use a isNull operation to find all of the geometries, all the table records that don't have geometry, right? Oh, no, it's back here. Back here. My bad. Let me fix this. Okay, here's the shape, right? Shape is none, right? It's no geometry. So what you would do then is after you've written your data, you would create this new data frame and send yourself an email and say, hey, these records don't have geometry, which means that they must be new because they're not in your data set. Or maybe they're outside of the boundaries of your municipality and you have to add them to a whitelist or something. But then this would be what that is. So that's how you would know that you have manual work to do. So that's the end. And the question part is here. So I'm not going to say, do you have any questions? I will say that this stuff is super fascinating. And we can also take a look at some of the outputs from those specific data sets. So I am happy to also share some things because I know deep down in my soul that people love party favors. So I have a party favor for this, and it is the code. It's the code. Here it is. I also wrote YAML for Pro 2.7 and a new YAML for Pro 2.8 because every time they have a dot change, it breaks everything. So you'll need to remake your YAMLs from scratch. But ArcPy is now on the Conda repo. So it is, you can download it and make your own ESRI environment. So here's the stuff from the counties, and you can tell that, geocodes a lot of them correctly. And then doesn't geocode some of them correctly, right? Anyway, so yeah, I'm looking through the no mic voice chat now. Post the code somewhere, check. Do you always use Geopandas for the joins? No, so I actually didn't use Geopandas for this join. Let's see. Okay, so this is the spatial. So the ESRI implementation of the spatially enabled data frame retains, it inherits from the pandas library, right? So since the pandas library has a join, the spatially enabled data frame has a join. You can't right now inside of the distribution that Esri has with ArcGIS Pro, can't use Geopandas, so you actually have to create your own environment or clone the environment and then add some stuff to use Geopandas. But yeah, you're using just regular old pandas join to do this operation. And I like it because it's fast. It's a lot faster than the geoprocessing tool joins. So does Geopandas handle big data well? I do not have experience with that because I'm a local government type, and I don't do things with big data per se. And to be honest, I've only just recently started playing around with Geopandas. Yes, that's if you wanted, right? For big data, I know that there's a library called Dask that is an implementation of pandas for big data, but I don't know what geo things Dask has. But I'm interested in it, right? I want to play around with big data. I just don't know that I really have a lot of options with it yet, without, a bunch of like IoT sensors and stuff, which, cities are getting. So I'm sure that in the future I'll be working with it, but for right now, no. Let's see. Anything? Oh, right. So, yeah, so this is the counties thing. Then for the bounding box, you'll see it's totally, really perfect. Look at that, just so good. Everything happened exactly the way it was going to be, which is great, except for the amount of data was not good. So instead, here's the zip code thing, right? So it's more or less exactly where it should be. And then, you've got all your other things across the area that are not geocoded correctly. And that's that. Yeah, that's that.
Well, thank you so much, Jordan. I really enjoyed that. And let me just say, I am one of those people who will sit here and write out the entire dictionary. So when you exported the CVS file, um, sounds like a life changer for
Well, hey,
sure.
I'm gonna out myself right here. When I first did this, I rolled my eyes and wrote out a dictionary. And I was like, oh, I'm so clever. I'm using a dictionary to tell it what data types it's gonna do. And then when I was writing the presentation, I was like, oh no, I'm not clever.
No, it's pretty clever. And I also like how the website gives you the field type. I can't tell you how many times I'll go looking for like through the metadata because I'm trying to duplicate the exact same um, data, but I need to get like the field type correctly, and it's a treasure hunt for sure. So that's very nice how they have that all displayed. Depending on however you plan to use it, it's always nice to have that.
Yeah, I was really impressed with this. Open data is degrees of openness. And when I first saw this, it was really outside of my wheelhouse. And I was like, yeah, I don't know. They've got like this make a map thing, and I tried playing around with it. I was like, I don't really like this. I really just wanted to be with the tools that I'm used to having. Um, but just a data dictionary goes miles for sure.
I couldn't agree more. I'm not sure if we have maybe one more question coming through, but if there's any other questions, would you be okay if they were to send you a message, Jordan, or maybe just kind of at you in the chat? Because sometimes, people they're like, "Oh, do you have any questions?" Like, nope. 15 minutes later, I wish I would have asked this.
Well, I'm sure if you don't know, if no one knows, I live on the Discord. I live for the Discord. So yeah, just at me, and I will roll on by. Um,
Perfect, perfect. You live on the Discord. I live on the Discord too, so it's no shame, no shame in that game. But we certainly appreciate your time, and I'm positive everyone really appreciates your presentation and you sharing the knowledge, sharing the code. So thank you for sharing your work.
oh yeah, yeah. Oh, it looks like a buzzer beater. For me, coding is life. There's uh in the local government space, there's a lot of, oh, I'll just work the 8 to 5 and you'll get it done when you get it done, right? Unless there's like an emergency and then it's like it has to be done. It's like, well, it can't be done. Um, I started my career in GIS drawing land parcels. So using meets and bounds deeds in Texas from the 1800s to today, and just like drawing stuff over and over, and I just hated it, right? Especially like river deeds because you've got like 200 calls because it's by a creek or something. So for me, I spent all that time in my head thinking how much I could avoid doing manual labor like that. And so when I got an analyst job working in local government, that's when I started realizing, oh, I can do other things with this, right? And so a lot of what we have is dealing with other business systems, like third-party software that have databases. And so it's like, oh, I want to use that data, but I don't want to be inside of their bespoke software system to use it. So that's when I really got serious with coding and SQL and Python just to be able to integrate those databases together and start producing interesting data sets, right? So we were able to make like a garage sale map because our town, my previous town, required you to have a permit for a garage sale. And I wouldn't have been able to do that without programming, right? So we had, like food permits that I was updating by hand before that, because we only had things on PDF. So if you want to be able to play with a lot of data, or if you want to be able to have frequency of data, you can't be hand entering it. I mean, someone might have to hand enter stuff, but if they're doing it inside of their business systems where they would have been doing it anyway, then you can grab that data out. So, utilizing the workflows of others to enrich your own GIS is the way to go. And
When you
that's
were,
it. I'm gonna get off that soapbox.
I was gonna say when you were talking about your parcel experience, it reminded me when you told us the story about like your fail when you first started working out, about missing uh, the PDF, and I just want to say that was
Oh,
a great story. You
yeah.
should share
So,
that if you feel like it.
okay, yeah. So I forgot to when I was saying that on the clubhouse, I forgot to mention like the most important part. So the story is there's this guy at a county, and he's like the guy in charge. He's the person that writes our checks to the consultant ITGIS company that I was part of, right? And so we just write the deeds. And I sent a deed back, and I was like, "Hey, this deed is incomplete. It doesn't close. You need to tell the surveyor to go back out there and survey correctly." Um, and and so he like sends me another email. I'm like, do it again. I'm at this point, I'm not even like looking at my work anymore. I'm just like, no, 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 fix it. And then it keeps coming back and just looks the same. It's like, and then so finally, uh this guy's like, hey, I've told the surveyor as many times as I can, but he's saying that you're wrong. And I was like, fine, fine, I'll look at it. I'm like doing it, and I realized that there was like another PDF page that I had been overlooking maybe this whole time. So maybe it was right from the beginning. And then it was just horrible, right? And so it was a really tough experience for me because I had to go forward that email to my boss and say, hey, I really messed up and I'm sorry. And everyone was a really good sport about it. But what that did to me, besides the emotional scarring, is that now before I tell anyone outside of my organization that they're wrong about anything, like I triple and quadruple check my work, and I end up spending like 2 hours like trying to prove all the different ways it's wrong, and then what all the different solutions are to make it right before I send anything out. Um, and it's an obsessive compulsive thing, but because of that experience, I always do that now. The best projection. So the best projection for our area is NAD 83 State Plane 4202. And I actually just last night converted us over to the 2011 revision. Uh, I'm really excited about the 2022, but scared about time epochs. So I'm just going to let everyone else kind of play around with that for 2 or 3 years before I jump into that. But the best global projection, I'm not trying to weasel my way out of that question, is either it's a toss up really, either the Waterman butterfly or the Dymaxion. Those are my faves because they look super futuristic, and also help remind us that we're on a spaceship Earth together.
Well, thank you for sharing your emotional scars again. We all appreciate that. If there are no more further questions.
That's
No?
great. That's great. Thank you so much, everyone, for spending your Friday with me. Thank you, MScope, for creating this beautiful community that we can all be a part of. I appreciate it.
Thank you. I have a lot of help.
Thank you. Nice presentation.
Why is Nuno so wild all the time?
Hype.
Yeah, thank you. It was really nice.
Well, thank you all for coming. I really appreciate it, and so did Jordan. So thanks, guys.